Assalamu alaikum. In this lab, we are going to implement a priority queue data structure and its implementation as an array in Java language. So this lab will basically introduce the concept of priorities in queues, as we have discussed in the class that there are certain situations, certain conditions where the first in first out architecture of data insertion and deletion is not just enough. For example, in case of a queue for patients in emergency room, in that case, just the first come first serve basis kind of queue is not does not serve the purpose, because if there is a more urgent case, then it should be dealt with uh, before the ones even waiting earlier in the queue. So in that case, we need some kind of priority or some kind of importance or a state of emergency with the data elements to be processed. So this priority queue is the solution for such kind of for overcoming such kind of limitations in FIFO structure. Then this lab will also help you understand and comprehend the arbitrary insertion and constant deletion from priority queue, because in queues we had seen that data is always inserted at the rear end and it's deleted or dequeued from the front end. But in case of priority queue, the data is no more inserted at the rear end only, and the data is inserted arbitrarily depending upon the position which befits this data item we are going to add to this queue. So we have to look for the proper place of this data element in the queue before inserting. So that's why it's an arbitrary insertion. It does not just follow the rear pointer. So even some implementations, they don't use rear pointer with the queues anymore. So as shown in this example, that in this figure that insertion is happening at one end and deletion is happening at the other, like a queue. Okay, we will discuss that. This can also be a case where the insertion is happening just insertion is not arbitrary and it follows the same technique as of a general queue, but in that case deletion would be arbitrary, because we have to see we have to find out the data element or item with the highest priority before deleting. So either you have to implement an arbitrary insertion or an arbitrary deletion. Okay, so this is just to demonstrate the working of a priority queue, that the front end is here and the rear end is here initially when this queue would be empty, and the first element, which is 100, comes, and you just add that 100 to this you just add that 100 to queue. Then comes the other element 500. So you look for this, you compare this 500 with the incoming 100, and if it's smaller than this 100, then you shift this 100 towards the left and place 500 here. But since this is not the case, so 500 is placed here, then 750, then 900. So it gives birth to an ordered list or an ordered sorted list. So this ordered once this queue becomes ordered in terms of priority, then when we have to remove or dequeue, we just dequeue the element at the front location, which would be the highest priority. In most cases, highest priority is treated equivalent to the minimum value. For example, consider to better memorize this, consider a situation, for example, with printer, when there is a document of 400 pages and the document with 1 page or 2 pages. So the document with smaller number of pages should be printed earlier, because the document with 400 would take a lot of time, and we can get done with the document with smaller number of pages. So usually in most implementations, this dequeue or remove function is also called remove min or extract min, because we find out the minimum value and retrieve it and delete it. So here, for example, the front end is here, the rear end is here, as data has been put up, has been getting inserted. So there is a new element 37, and the rear is here 21. So we first check if this 37 is if this 21 is greater than 37, which is not the case. So we go to the next element. When we see this 24, we shift this 21 upwards, and then we check with the other element 24. So this is also not smaller than 37, so we shift that also one upward, and we check with 61. 61 is greater than 37, so we just place this 37 above 61 and below 24. So this is the representation of a priority queue of insertion into priority queue. So the basic operations priority queue supports are the front method, which basically just returns the element which is to be dequeued next, or which is the highest priority element. It doesn't remove or dequeue that. Insert item. So this function inserts an item into the priority queue. The steps that we would be implementing are that we first have to check whether priority queue is full, which we check by so we check if the queue is full. Then, for example, we can check it easily, conveniently, by keeping a counter for the number of items. So if that number of items is equal to maximum size, so if this is true, then we throw an exception or print a message. Otherwise we otherwise we check if the queue is empty by comparing this number of items with 0. If this is true, then we insert that number of item index and increment this number of items, because number of items would be 0 in that case. So we would insert at this 0th location. In this case, in this algorithm, we are escaping the use of another pointer front by making use of this number of items as an index as well, because number of items will be 0, and at the queue array of 0 we will insert the item, and we will increment this number of items. Okay, this is the case if the queue is empty. If queue is not empty, then what we do, we start at the priority queue, which is an item. We start at the end of priority queue. For example, from the last inserted element, or the top position, if you call it, or the front position, or number of item minus 1 position, because we need we are dealing with arrays. So if number of item is 4, then it must be residing at the fourth element must be residing at 4 minus 1 is equal to 3 at the third index. So we start with that, and then we check if the new item is larger. If the incoming item is greater, then what we do, if true, then we shift the queue array upward, because it means that at the top of the queue, at the front position of this priority queue, there is an element with higher priority, so we shift it upward. And if not true, then we're done shifting and break this rule. If that is if this condition is true, the item is greater than the one at the top of the queue array at the front index, or the n items index. If that is smaller, then we shift it up and compare this new item with the next element, as it is displayed here. Like 37 is compared with 21. 21 is smaller, so we shift this up and compare it with 24, and until we find the proper place. When we find this condition to be false, that the item is greater than queue array of j. If this is false, it means that now at the front of this queue array there is an element which has lower priority, because it has greater value. So it has lower priority than this new item we are going to insert. So we just break this loop, and then we insert the item at the empty space, which is queue array of j plus 1, because j has already been getting decremented. J is the looping variable which we initialize by an item minus 1, and we are decrementing it. So and after this insertion, we increment the number of items. So a remove function, it is straightforward. It has big O of 1 complexity. It takes a constant time, because we have already an ordered list in this queue array. So we just remove the element or item which is residing at the front index, or the n items index. So check whether queue is empty. In that case, throw an empty queue exception. Otherwise, if queue is not empty, return the item at an item's index and decrement n items. So this is the basic algorithm. Now we will quickly move toward the implementation of these algorithms, so that you see the running of this priority queue, and then you have to implement these algorithms, or you can use these from the video link from this video that we would be implementing. You can use this implementation, but now in this lab task, you consider that the data is just not a simple numerical values of the array. We consider that this queue array, basically the elements to be inserted in the queues are object of some class. That class has, for example, a string data, and the priority of these data elements or these objects to be processed comes from the number of characters in the string data of this object, you see. So for example, here we have the data item would be a class, let's suppose data item, and this class has, let's suppose, simply it has just a string, let's suppose name. Okay, now the queue array that you would be defining inside the queue, this priority queue class, would have the type data item. So you would be having a data item type of array and call it queue array, which would be new data item type of size whatever you create this queue array, let's suppose 5 or n, or you pass to this constructor or the size of this array. So now in this case, this data item array this queue array basically has data item objects instead of integers. Okay, and the priority is the priority of every object of this data item class of this queue array, it comes from the number of characters in string. For example, if you have a data item type of object d1 and you create this somewhere in main or in anywhere, and you pass it a value, for example Farhan, and then there is another data item type of object d1 is equal to new data item, and it has a type, it has the value, let's suppose Muhammad. So in that case, when you have to insert these two let's suppose we somewhere have we have already created an object of this priority queue. For example, let's suppose you call it PQ class. So we have a PQ of type priority queue. Okay, and suppose you define its constructor to accept its size. So I say 5. Now I can add this d1 and d2 into this PQ object by PQ dot insert, for example. Okay, and I pass it d1, and then I call it again insert d2. Okay, so these two commands should add this insert command should add this d1 and d2 according to the priority, which will be computed from the data item from the d1 and d2's strings. D1's value is Farhan, the string value, and d2 has Muhammad. So the number of for example, in this case, Muhammad would have a lower priority, and Farhan would have higher priority because it has less number of characters. So you have to implement this as a program, this functionality, and submit for this lab. So now I would just pause this video and set up a new class for starting implementation. So in the I have created I have created a class and called it PQ for priority queue. So what I need for this class is an integer which will be the size of integer maximum size. Okay, and then I need an array of type integer, let's suppose call it Q array, and then I need another integer n items. Okay, I can use this n items as a front pointer indicating the value with highest priority. Okay, I declare its constructor and I pass it an integer a, and I call it I initialize these for max size. I initialize max size with this a, and then I initialize the Q array as well. So Q array is equal to new int of size max size, and then I initialize this number of items with 0 so that initially the queue is empty. Okay, and then for example I quickly define the insert method. So insert item, it would not return anything, and it receives an integer item. And how it does this insertion is that first of all it checks for the fullness of this queue. So I compare it directly here. If an items is equal to max size, then just print a message, or let's use the exception queue class, which I guess I already I have as a class here. Okay, let's do this print a message. Okay, instead of throwing an exception, you can improve it yourself. System.out.println queue is full. By queue here I mean the priority queue. Okay, and we return else. Okay, we check if this n items is equal to 0. If the queue is empty, then what we do is here you can see the algorithm that if queue is empty, insert the item at an item index. Okay, so we just insert at queue array of n items is equal to the item that we pass to this priority queue, and we increment n items. Okay, so n items is equal to n items plus 1, or n item plus plus, or you can even reduce it to just one statement. For example, queue of array n items plus plus is equal to item, so it will first insert at an item at the index which is equal to n items, and then it will increments this number of items. And if this is not even the case, the queue is not empty, then what you do is you just start your search for suitable position for this item by if you see here, the third step of this algorithm say that start at end of priority queue, which is n item minus 1. So I use a for loop. For example, integer j is equal to n items minus 1, and j is greater than or equal to 0, and j minus minus. Okay, and inside this loop what I do is I check if the because in this case the values which this priority queue is accepting are integers, so I just have to compare the integers by checking that if this the incoming item, if it's larger than the queue array, then what it does is it has to shift this queue array of jth index. Okay, if this item is larger, then we have to shift this queue array of j. So what we do is queue array of j plus 1 is equal to queue array of j. Okay, and if this is not the case, what we do is we just break this loop. Okay, and because we don't have to shift this array, so after that, once we have broken the loop, it means we have found the location or we have reached to the end of the queue. Then what we do is we place at this empty space created, and that would be j plus 1. You can do the dry run to clear this out. Okay, okay, so this loop is just we declared this j looping variable inside this loop, so it's not being recognized outside the body of this loop. So let's declare it outside this body of this loop. Okay, so queue of j plus 1 is equal to item, and then you increment n items plus plus. So this is the basic skeleton of the insert item. Please notice that for your this lab activity, you don't have to just consider the data elements or items to be inserted as simple integers. So in this case, you will have to you will have the data item as we discussed here, written here. So in that case, these data items would be objects, and you have to process these objects here to find out the to make the appropriate place for the data item. For example, here j is equal to n items minus 1, it will remain the same, but here you are checking the item greater than q array of j. So there you will have to for that case you need to, for example, if d1 was the object, so d1 dot name dot length, somehow you will compare the length of the string inside this incoming data item and the length of the string of object residing on the top of this priority queue. So by that you will shift or insert the element. So after that, let's suppose quickly we define this what we call delete. Okay, delete method or dequeuing, and it returns an integer which is dequeued. So in that case, we check if the queue is empty. For example, here was the condition for empty queue. If an item is equal to 0, then we print a message that this queue is full. So we just s out empty queue, and we return some arbitrary figure like minus 999. Okay, otherwise if this is not the case, then what we do is it's pretty simple, that we just return the value which is at the n items n items index, so we just return that value by n items minus minus. Okay, we return this value at n items, and we decrement this n items. So this is the delete method. Okay, I guess this is the basic skeleton of this priority queue, the working of this priority queue. Give me a second so that I can make its object in the main and test it. I have to see which main is the current main of this project right now. Just give me a second. So in this main, we create the object of our priority queue class, call it PQ, new priority class of size, let's suppose 5. Okay, okay, there I guess we need to declare an empty constructor so that we can use this one. Okay, so what we do is we add some numbers to this pq dot what did we call it, insert, let's suppose 25, pq dot insert 30, and pq dot insert 15, and pq dot insert 10. Okay, so for a normal queue, how would it be? It would be something like it would have 25, and then at the rear end it would have 30, and then 15, and then 10. But how the priority queue should work? Priority queue should insert 25 first. Okay, the 25 is inserted, next is 30. So 30 is greater than 25, so this 25 moves to the next location and 30 comes here, and then it's 15, so 15 is smaller than 25, so it should just be inserted here, and then there is 10 should be inserted here. So it should have this order, it should be in order, so that the minimum value is at the front or the next value to be dequeued. Okay, so we didn't define a method for displaying this queue, I guess. So what can we do is we print a method. For example, here we make a method pq which we call it it returns bool is empty, and we just return number of items here. Okay, so okay, sorry, should return number of item is equal to 0. Alright, so okay, so in this here now we use this is empty method as while pq dot while not pq dot is empty. Okay, what you do is you dequeue the value from sout.println, sorry, sout.print pq dot what we call delete. So it should delete the value, and then it should add this. Okay, so let's see how does this behave. So okay, so I debugged the problem that earlier it was giving some different kind of running result. So it was because here in the PQ class, the remove method, I was doing n items minus minus. Okay, so it was not correct, because it would first return the index of the value at the index n items of the queue array. So if you see, for example, if there are 5, maximum size is 5 and n items is equal to 5, so the fifth element is at n items, the fifth element is residing at fourth index, which is n items minus 1. So it means that we first have to decrement n items and then access that index. So doing this just okay, so now you see the first element to be deleted is 10. However, the first one inserted was 25. The FIFO of the FIFO architecture of queue implies that this 25 would be deleted first and printed as the first element of this string or output, but the minimum value is deleted first, and then the next, and then the next, and then, so this kind of gives priority. So I hope this video clarifies some of the implementation details. Rest you can contact me for any further detail to implement the lab activity, which is given in this lab manual, which I will be sharing along with the video. Thank you very much.